Okay, so in this lesson, we're going to learn how to solve a system of linear equations. So notice these are linear equations, and this is a system because I have these two linear equations in one set, so to speak. And so we want to solve this system, and you want to do this by substitution. So always make sure you follow directions. The directions set to use substitution. And so when you solve a system, when you're solving a system, you're trying to find the ordered pair, so the ordered pair xy, that will make this equation and this linear equation true at the same time. So for example, remember when we graph a linear equation, so if you look at this linear equation right here, y equals 2x plus 4, there's the graph, right? So remember what it means to graph a line. So when you're graphing a line, what you're finding is the solution. So when you graph a line, you're graphing all of the solutions to that linear equation. So notice that this linear equation has two variables, x and y. So that's why we put it in a coordinate plane. So we notice we have an x-axis and a y-axis because this linear equation has two variables. And when you graph a line, you're graphing the solutions. So for example, you see this point right here? This point here that let's say is negative 2, 1. Negative 2, 1. So you see this point's on this line, right? So that means if I substitute in place of x, negative 1, and in place of y, 2, this equation will be a true statement. So watch. So if I go here and I do that, you'll see that when x is 2 and y is negative 1, I have negative 1, and we'll see that's going to equal to 2 times 2, oops, sorry, y is 2, excuse me. Y is 2, x is negative 1, excuse me. So 2 equals 2 times negative 1 plus 4. 2 times negative 1 is a negative 2, and negative 2 plus 4 is 2. So those two sides are equal, right? And so therefore, this is a solution to this equation right here. So when you're graphing a line, rather, you're graphing the solution. The same thing is true for this line. This line right here, 3x plus y equal 9, there's the line. So all of these are solutions. Now, when you're asked to solve a system, and let's say my system is these two lines right here. So these two equations, y equals 2x plus 4, and then 3x plus y equal 9. So when you're solving a system, you're finding the ordered pair that makes both of those equations, both of those lines true at the same time. And basically you're looking at the intersection of those two graphs. And so notice the intersection is right here, and that's the point 1, 6. And notice when I substitute 1, 6 into x and y in both of those equations, both of those equations are true at the same time. So watch. Let's look at this one. Y equals 2x plus 4. So so this time remember it's 1, 6, right? So x is 1, y is 6. So I get 6 equal 2 times 1 plus 4, and 2 times 1 is 2, and 2 plus 4 is 6. So they are equal. Same thing for this equation, 3x plus y equal 9. 3x plus y equal 9. And so in place of x, I'm going to substitute 1. In place of y, I'm going to substitute 6. So I get 3 times 1 plus 6, and I want to see if that's equal 9. 3 times 1 is 3. 3 plus 6 is 9. And so they are equal. Okay? And so when solving a system, you're finding the ordered pair that makes both of those equations true at the same time. And so that's what you want to do here. So you want to find the solution to this system right here. But you don't want to do this by graphing. You want to do this by substitution. Okay, so you're trying to find out the ordered pair that makes both of those equations true at the same time. You know that this equation has an infinite number of solutions, right? That's a line. So a line is made up of ordered pairs that makes this equation true. Same thing here. This equation has an infinite number of solutions. But together, when you put those together, there's only one point where those two lines are going to intersect. And that's what you're interested in finding. What is the solution that makes both of those equations true at the same time? All right, so let's do this by substitution. So when you go by substitution, the first thing you want to do, so here's the step, and so this is one of your resources. Step 1, you're going to isolate one of the variables. And so you're going to pick an equation, either the first one or the second one, and you can get the variable by itself. Well, notice that this is easy because the second equation, the variable is already by itself. So step 1 has already been done for you. So step 1, you're going to say use y equals 3x minus 7, something like that. Okay? Then step 2, substitute the expression from step 1 into the other equation. The resulting equation should have only one variable, not both x and y. So notice this equation right here, and in fact both of those has an x and y, right? All right, so step 2 says this. Take this expression right here for y, 3x minus 7, and substitute it into the other equation in place of y, because that's what you're saying y equals. All right, so here's step 2. So you're going to say 2x minus 3 times, in parentheses, because all of this has to be multiplied by this negative 3, right? So put that in parentheses. So 3x minus 7, and that's equals 7. And so notice the statement right here that says the resulting equation should only have one variable, and it does, because look, all you see is x. And then all you do, step 3, is solve the new equation. And this will give you one of the coordinates. All right, so let's go ahead and distribute the negative 3. So I get 2x. Negative 3 times 3x is a negative 9x. A negative 3 times a negative 7 is a positive 21, and that's going to equal 7. And so 2x minus 9x is a negative 7x plus 21 equals 7. Subtract 21 from both sides and combine like terms. I get negative 7x equal 7, and a negative 21 is a negative 14. Divide both sides by negative 7, and then simplify and reduce. I get 1 times x is x equal a negative 14 divided by negative 7 is a positive 2. So far, in terms of my solution, I found the x coordinate. Now remember, a solution is a point. So you're finding the solution of the system. So the solution is a point. So you got to put that in parentheses. So here's the x coordinate. It always goes first, and then we got to find the y coordinate. All right, so let's go ahead and find the y coordinate. So then step 5 is solve for the other coordinate. All right, so to solve for the other coordinate, since I know x, I can go back to any of these equations here and solve for y. I'm going to go back to this one because this is the one that's easier to deal with, right? It doesn't matter. You can go to this one or this one. I'll show you it doesn't matter. But this is the easy one because y is already by itself. So this is going to be step 5, I guess. All right, so step 5, you're going to substitute this into the other equation. So y equals 3 times x is 2, minus 7. And so 3 times 2 is 6. 6 minus 7 is a negative 1. And so there's your y coordinate. And so that's your solution. And you can always check. You don't have to, but you can always check. So let's check to see if this is true. So let's check to negative 1. So it's easy to check these, especially when they're integers. So see how those are integers? So it's easy to check your solution. So go back into each of those equations, and where we see the variable x, substitute 2. Where we see the variable y, substitute negative 1. Verify that's true, especially if the coordinates are integers. It's so easy to check it if those are integers. So we have right here, so let's check. So we have 2 times x, so this is the first one, and so that's 2 times 2. And then minus 3 times y, and y is negative 1. And I want to see if that's going to equal 7, right? All right, so 2 times 2 is 4. A negative 3 times a negative 1 is a positive 3, and 4 plus 3 is 7. And that's equal. Now let's check the other one. Y equal 3 times x minus 7, right? So y is negative 1, x is 2. So negative 1, I want to see if that's going to equal 3 times 2 minus 7. 3 times 2 is 6. 6 minus 7 is a negative 1, and they are equal. All right, so it's pretty easy to check. And if you were to graph those, two equations, they would intersect at this point right here, at 2, negative 1. So that's how you do this by substitution. So let's look at another one. So this is going to be number 2. So in number 2, we have this system. So we have 3x plus 2y, 3x plus 2y equal, and let's say that's 1. And then the other one is x minus 5y equals 6. So x minus 5y equals 6. All right, so you're trying to find the solution that makes both of those equations true at the same time. All right, so let's do this by substitution. Always follow direction. This says substitution, so you must use substitution. So step 1 is you have to isolate one of the variables. So you got to look at your two equations and then determine which variable is easier to get by itself. So remember, the variable that's easier to get by itself would be the one that has a coefficient of x being 1, right here. Now, that's not always going to be the case. So it could be that all these variables here do not have a coefficient of 1. But if it does, then that's the easiest one to get by itself. So you see how this right here, that coefficient is 3, that coefficient of y is 2. So if you were to get x here by itself, you would have to divide everything by 3, and you would have fractions. So you don't want fractions. Now, sometimes you have no choice but to deal with fractions, but if you don't have to, then don't deal with fractions. And so if you look at this one, this equation here is the one that's the easiest to get x by itself. So let's do that one. So step 1, I'm going to take this equation, x minus 5y equals 6. I'm going to solve for x. So I'm going to add 5y to both sides. And so when I add 5y to both sides and combine like terms, I get x, this is 0, because those are opposites. So I get x equal 5y plus 6. So that was step 1. So I get the variable by itself, right? So then step 2 says, then I'm going to substitute that expression from step 1 into the other equation. So meaning that I'm going to take this right here, that's step 2. I'm going to go to the other equation, which is this one. And wherever you see the variable x, I'm going to substitute 5y plus 6. So here's step 2. So step 2, you're going to say 3 times x. Remember, x is this expression, 5y plus 6. And then plus 2y equal 1. So notice that bullet right here. The resulting equation should have only one variable, not both x and y. So notice the only variable I see here is y. All right, so let's go ahead and solve this linear equation. So I'm going to distribute. So I get 3 times 5y is 15y. 3 times 6 is 18. Plus 2y equal 1. Combining like terms, 15y plus 2y is 17y. So I get 17y plus 18 equal 1. Subtracting 18 from both sides. Combining like terms, I get 17y equal a negative 17. Dividing both sides by 17 to get y by itself, I get y equal a negative 17 divided by 17 is a negative 1. So I found, and so far, my solution, I found the y-coordinate of my solution. The y-coordinate of my solution is negative 1. Now all I have to do is find the x-coordinate. So to find the other solution now, that's going to be step 4. So step 4, we're going to substitute the result from step 3. So this is step 3 right here, where you to solve. So I found the y-coordinate to be negative 1. So you're going to substitute the result into either of the original equations. So you can go back to either of these, and where we see the variable y, you're going to substitute negative 1. Again, it does not matter which one you use. I'm going to go ahead and choose the other one. Now, I'm going to say this, though. So if you did step 1 correct, then you can go back here and solve for x. So watch. So look. So assuming you did step 1 correct, now that's only assuming you did step 1 correct, because if step 1's incorrect and you do all this work, then obviously this is not going to be correct. So that's why they're telling you, just in case this is not correct, always go back to the original equation. All right, so always make sure you do that. All right, so let's assume this is correct. So you can go back here because x is already by itself. So let's find x. So So we're going to have x equal. So this is step 4 and 5. So step 4 and 5. So remember, step 4 and 5 is substitute the result into step 3 into either of the original equation and solve for the other coordinate. All right, so 5 times y, which is -1, plus 6. 5 times -1 is a -5. -5 plus 6 is 1. And so there's your solution. So x is 1, y is -1. But here's what they're saying, though. So they're saying you should really go back to one of the original equations. So I'm going to go back to the first one. So let's go ahead. So step 4 and 5, we're going to solve for x. X, because I already found y. Y was -1. So when I do that, I should get the same value for x, which is 1. All right, so we have, so I'm going to go back to the first one. I'm going to use the first. It does not matter, the first or second. So 3x plus 2y equal 1. So in place of y, I'm going to substitute -1. So I get 3x plus 2 times -1 equal 1. So that becomes 3x. 2 times -1 is a -2 equal 1. Adding 2 to both sides, I get 3x equal 1 plus 2 is 3. This is 0. And divide both sides by 3. And look what you get. You get x to be 1. All right. So that's your solution. So remember, it's always easy to check, especially if those are integers. So always check. Let's check the solution. You got to go back to the original, though. So in place of x, you're going to substitute 1. And in place of y, you're going to substitute -1. All right, so let's check. So 3x plus 2y equal 1. So let's check that one. So 3 times x, x is 1, plus 2 times y, y is -1. So 3 times 1 plus 2 times -1, and I want to see if that's an equal 1. 3 times 1 is 3. 2 times -1 is a -2, right? 3 plus a -2 is 1, and they are equal. All right, so now we got to check to make sure this one's true also, using that point. So the other one's x minus 5y equals 6. So in place of x, I'm going to substitute 1. In place of y, I'm going to substitute -1. And I want to see if that's equal 6. Well, -5 times a -1 is a positive 5. So 1 plus 5 does equal 6. All right, so there's your solution. So solution is 1, -1. All right, so that's how you're going to use substitution. So substitution involves this idea right here. Okay? All right, let's do one more. So this is going to be number 3. So number 3, I have, all right, there's number 3. I have 2x plus 3y equal, and that is, it looks like 10. Let me make sure that's correct before I go on. All right, let's just double check. All right, so that's actually 16. All right, 16. And then the other one is -7x minus y equal 20. All right, so we're going to do this by substitution. Now, be strategic. If you don't have to have fractions, then don't deal with fractions. Be strategic. Think about each of those variables and which one you can use, so that way you don't have any fractions to deal with. All right. Now, sometimes you have no choice but to deal with fractions. But if you don't have to, then pick an equation in which you will not have any fractions. So, for example, if you look at that first equation and you divide both sides by 2, then this is 3/2, and this would be 16 divided by 2 is 8, right? So you'd have a fraction here. If you divide both sides by 3, this becomes 2/3, and this becomes 16/3. So you have fractions. If you look at that second equation, if you divide both sides if you want to get x by itself, if you divide both sides by -7, then you have a fraction here because the denominator would be -7, and then you'd have -27s as well. So you'd have fractions here. But look at this variable y. Now you may say, but it's a -1 right here. That's okay, because when you divide all parts by -1, you have integers still. You don't have any fractions. So that's the one we're going to use. So step one is we're going to take the second equation and we're going to solve for y. And notice it's so much easier just to just to bring this y to the other side. Because look, if I add y to both sides, see, look at what happens. I get negative 7x, this is 0, equals y plus 20, right? And then if to get y by itself, I subtract 20 from both sides. And so this is 0 right here. I get y equal negative 7x minus 20. And y is already by itself. See how easy this was? All right, now once you get y by itself, remember what's the next step? Step 2 says I take this expression right here and I substitute it into the other equation in place of y, because that's what I got by itself, y. So y is negative 7x minus 20. All right, so this will be step 2. So step 2, so you get 2x plus 3 times y. Y is negative 7x minus 20 equal 16. And then notice you only have variable x now, so you're going to solve this linear equation. So let's go ahead and distribute the 3. So I get 2x. 3 times negative 7x is a negative 21x. 3 times a negative 20 is a negative 60 equal 16. Combining like terms, 2x minus 21x is a negative 19x, right? And then minus 60, oops, that's a 60 right here. Let me do the 60 equals 16. And then adding 60 to both sides, I get negative 19x, this is 0, equal 76. And then I'm going to go ahead and divide both sides by negative 19. And when I do that, let's see, 76 divided by negative 19 equals a negative 4. So I found the x-coordinate of my solution. So my solution so far is negative 4. I got to find the y, I got to find the y-coordinate. Now remember, to find the x-coordinate, to find the y-coordinate rather, you should go back to one of these just in case you made an error here. But assuming you did all this work correct, you can go here. So you can go to this one. So to solve for y, now we're going to solve for y. So you can go here where y is already by itself. You get negative 7x. Oops. So you get, well, let me go ahead and write it out. Negative 7x minus 20 equal y. That's a y here. And so in place of x, I'm substituting negative 4. So negative 7 times negative 4 minus 20 is going to equal y. Negative 7 times negative 4 is a positive 28, and 28 minus 20 is a positive 8. So there's your y. So y is 8. So that's your solution. But if you go back to any of these other equations, for example, if we go ahead and we substitute negative 4 right here into the second equation, does not matter, either this one or this one, you'll still get the same answer. So let me show you. So now what you're going to do is if you go back to, let's say, this one, so let's say you want to find y and using one of these equations. So I have negative 7x minus y equal 20. In place of x, you're going to substitute negative 4. So negative 7 times negative 4 minus y equal 20. This is negative 7 times a negative 4 is 28. 28 minus y equal 20. Subtracting 28 from both sides, this is 0. I get negative y equal negative 8. Remember, negative y means the same thing as saying negative 1 times y. Divide both sides by negative 1, and then simplify. 1 times y is y. See, negative 1 divided by negative 1 is 1, right? So 1 times y is y equal, and then negative 8 divided by negative 1 is a positive 8. So I get the same thing, right? All right, now remember, since those are integers, it's so easy to check. So let's check this. So let's check our answer. All right, let's go ahead and check. So we go back to the original equation, though. You must go back to the original. So the first equation is this one, 2x plus 3y equals 16. So remember, what you found is that this point will make this equation and this equation true at the same time, meaning that if you graph it, that's going to be where the two lines intersect. All right, so let's check. So here's the first equation, 2x plus 3y equals 16. And so in place of x, you're going to substitute negative 4, and in place of y, you're going to substitute 8. So I get 2 times negative 4 plus 3 times 8, and I want to see if that's going to equal 16. 2 times negative 4 is a negative 8, 3 times 8 is 24. A negative 8 plus 24 is 16. All right, so far we're good so far. Now let's go ahead and do the second equation. So the second equation is negative 7x minus y equal 20. So in place of x, substitute negative 4. In place of y, substitute 8. So negative 7 times negative 4 minus 8 equal 20. I want to see that equals 20. Negative 7 times negative 4 is 28. 28 minus 8 is 20. All right, so that works. So there's your solution. Okay, so that is how you are going to solve a system by substitution. All right, so that will be the end of this lesson.